Hello all and welcome to an exciting video lecture in engineering mathematics brought to you by your instructor Srinidhi from Bharadwaj Academy. We are in the first module of differential calculus of part 1 of my 4-part series on engineering mathematics. This is the second video lecture on successive differentiation, applications of the formulae that we learned in the previous video lecture. So we'll be solving our first problem now. This is our first problem which is on the screen here. This can be written as the following form. Now, which of the uh, previous formula are we going to use today? Yes, one of these. But there is a small catch. Only one term exists here, sine and cos, individually, right? But in the problem, we have so basically here we have a product of cos and sine terms mixed. You can convert the product of many sine cos terms into sum of sine cos terms. How? Is there a shortcut or something? Yes, there is. But it's not a shortcut. It's a concept. It's a principle known as the transformation principle. Here is the basic essence of transformation principle. How do we apply this? Before that, pause, take a deep breath, and forget every transformation formula you might have by hearted before, because I'm going to explain you a quick strategy to obtain the same. For that, we have to recollect these basic trigonometric identities. I guess you can remember them because it has a nice pattern, right? That's nice. But how is it relevant to us here? This list of the formula is our menu card from which we have to order our dish, right? Because we cannot order everything on the menu, right? We only take what we need and what we can eat. Let's take a look at our problem actually. It says e power 3x cos x cos x and sin x. Take the leftmost terms cos x and sin x. Now search for this cos x sin x term in these four formulas. Of course it has to be sin x plus y and sin x minus y. Because you have cos and sin, there is no way these two formulas are going to be applicable. Now we can either add or subtract these equations. We'll get the same result. Why? Because we have same value here, x and x, right? Now we'll add them. So cos x sin x will actually yield us. So what happens when you add them? Sin x plus y plus sin x minus y. Now sin x cos x, sin x cos x 2 times. So you have to divide by 2 because 2 will be left here. There will be 2 terms, right? So what is sin x plus y? Sin x plus sin x is sin 2x plus sin x minus x sin 0. Sin 0 is 0. So we are left with this stage. This is the first stage of solving our problem. In the next stage, we reapply this concept again. So we have a combination of cos and sine here, right? So we have to take these equations again, but now we have to be a bit cautious. We cannot choose the option like either add or subtract. Since you don't have the same terms here, right? You have x and you have 2x here. So we have to choose to add or subtract based on the logic that we need to retain the cos term first and the sine 2 term, 2x term next. But as you can see, if we add them, the term will get collapsed, right? So we have to subtract these equations here. So we'll subtract this equation from this equation. Subtract 2 from 1 basically means sin x plus y minus sin x minus y. So what do we get here? Cos x sin 2x. We get it as sin x plus 2x is 3x minus, right? Minus sin x minus y. So we get it as sin of minus x divided by 2, right? Now, sin of minus x we know is minus of sin x. So this will change into sin of 3x plus sin of x by 2. Yes. So we are left with this. Now let's go ahead. Now we are left with the refined form. So we have to directly apply the formula here, right? So direct application of the formula will give us direct results. As you can see, this is a square plus b square here. We get a constant term here and also here. And also 3 by 3, right? It's 1. Yeah, 3, 3. So tan inverse of 1 is pi by 4 or 45. And 3 we have kept it as it is. Let's take a look at another kind of problem. Now, is this really a standard form? No, right? What do we do then? We bring it to its standard form. In order to do that, we have to apply the concept of partial fractions. As per the concept of partial fractions, you can write a fraction into two partial fractions. Basically, a sum of two partial fractions will yield you the required fraction or the total fraction. Now, a and b are constants here. A and b are unknown constants. How to find them? We have to form an equation by cross multiplying. When you cross multiply, you have to take the LCM here. So you'll be left with an equation of this format. A into x minus 5 plus b into x plus 1 is equal to 3. In order to find the values of a and b, we need to substitute the roots of x. Now x has two roots here. If you substitute x is equal to 5, you'll get this cancelled. If you substitute x is equal to minus 1, this gets cancelled. So apply the roots separately. What happens when x is equal to 5? This whole term gets cancelled, so we'll not bother writing them. So b into 5 plus 1 is 6 is equal to 3. So b will be equal to 3 by 2 is half. Now if I substitute the other root, 1, I don't think so. It is minus 1 because plus 1 minus 1 gets cancelled. This whole term collapses. B is eliminated. We have only a. So a into minus 1 minus 5 minus 6 is equal to 3. A is minus half. Recombining them by substituting a and b, the final fraction that we get is something of this format. So we have successfully managed to convert a total fraction, which is 3 by x plus 1 into x minus 5 into a sum, or basically here the difference of two partial fractions. Now can we apply the formula? I think we can, and the formula is, yes, formula of 1 by ax plus b. Direct application of the formula, we get this result. Thank you for watching this video. Please make sure to like this video and subscribe. Also leave in the comment section on any suggestions, feedback and shortcomings in this video. Stay home, stay safe, bye.